Okay, so back to Rhino we go. Today we're going to talk about unrolling surfaces in Rhino. And I think this is one of the more advanced topics that really showcase what Rhino can do. And many times we're designing some kind of a 3D model. We need some way of actually building it in real life. And Rhino has the ability of taking a complex twisted surface and essentially unrolling it and laying it flat such that you could glue the pieces back together and create your building. And this is, at its simplest form, the kind of thing that you would do in 130 when you make those shapes and you glue them together and you fold them. It's the same concept. The difference here is we can take something that's a twisting, weird shape and unroll it, glue it together, and it would become that twisting, weird shape. The caveat to that is that the only surfaces that Rhino can unroll are what are called ruled surfaces. And that means that you can twist as much as you want, but there always needs to be a straight line from one edge to the other edge. So if we were to look at this edge, for example, it scoops in and then goes back out, and etc. But there is always a straight line from one edge to the other. This, same shape, same look, instead of having a straight line from this edge to that edge, see how it goes out just a little bit? Likewise, of course, it's curving in this direction. It's kind of like a globe or an orange. An orange is probably the best example. You can't peel an orange and have the resulting peel lay flat without splitting it somewhere. Right? You end up making a little spiral and then it would lay flat. But in the process of making that spiral, we have some problems. It's not truly accurate. These straight line, what are called ruled surfaces, are very, very easy for Rhino to unroll and to use. And so we're going to go through the process of creating these unrolled surfaces. I have a variety of shapes here. Some of these buildings were from last class because the complexity works nicely for what I'm talking about today. What I'm going to ask you guys to do is to unroll or attempt to unroll the building that you've designed thus far and done renderings of. Some of you will not be able to unroll your building. I can tell you that right now. I've seen the buildings and I know that they won't unroll. If you're in one of those categories, you need to simplify your building and or transform it into something that will unroll. Part of your assignment 203, which is due after spring break, so you've got lots of time still, is to create what we're creating today, and that is to unroll the building and make the laser cut component that would allow you to cut it out and glue it back together. I do not, however, require that you actually cut it out and glue it together. There was a time way back when I did make you go do it, but I've decided that doing some renderings is more valuable. You're going to do renderings, but you're going to show me that you have the skill set to actually be able to do this, because down the road you'll be in 221 or you'll be in some future studio and you'll need to do this. And I want you to know how to do it so that it becomes easy for you. Okay, so we're going to look at a variety of these examples and how they unroll. I'm going to start with a very, very simple building here, which is essentially all straight. There's a little bit of a twist on the side, but the segments are rather straight, and I want to walk through the unroll process in this particular piece. So first thing that I need to do is I need to make sure that as much of the building or as much of the poly surfaces as possible are joined together into one poly surface. And so if, for example, I had this and it was separate pieces, including the top and the bottom, I would need to select all of those separate pieces, that, and join them together. It's not required as part of the unroll, but it will make the process significantly smoother if we do it that way. So now that those are all a joined poly surface, the unroll process is as simple as typing unroll or unroll SRF, or going to, I forget, I think it's under surface. I never do it from the menu. Yeah, surface, unroll developable surface, which is also unroll SRF. So unroll SRF says, obviously I already had it selected. Then it says select curves on polysurface to unroll, but then there's a series of options. We want to pay attention to these options. The first one is, do we want it to be exploded into pieces or not? Generally speaking, you want it to be exploded to pieces, yes, because if you don't explode it into pieces, there will be surfaces that overlap on each other, and you'll have to do it manually afterwards. So you might as well just say explode. The next thing is labels set to yes or no. I like to turn labels set to yes, because otherwise figuring out where the various pieces go is a really big challenge, and what unrolled where. So we're going to turn labels on. So we have explode yes, labels yes, and then keep properties we'll set to no. I will also, in the process, create a new layer and make that layer active. And I'm going to call that layer, oh, I can't change it right now until afterward. I'll call it unroll. So with that selected, I'll go ahead and hit enter. And what Rhino does is it assigns my building edges numbers. So we look at the top here. I have 0, 1, 2, and 3. And then it unrolls the various pieces of my building. There's the top of the building, 0, 1, 2, and 3. So I get those numbers assigned, but that also gives me numbers on the sides of my building. So there's 3, for example. So what I can do now is, let's look at this in the top view. I can look at the pieces that it unrolled for me there. Let's move them away from the origin. By the way, the unroll surface always puts the unrolled surfaces right at the origin. So if I'm going to do another unroll, it's helpful to move them away. And now I can look down at these surfaces and I can say, OK, well, let's see how these line up. So we know that 3 and 3 should line up. So let me go ahead and move. And then let me do a rotate. So 3 and 3 line up. Then I can say, OK, well, what else do I have that lines up? Well, 1 and 1 would line up. So let me move 1 and 1. And let me go ahead and rotate that one. To right there. OK, so those two line up. And we could see that as I folded it, it would come together. Now I can say, OK, well, 0 would line up with 0. And I can move it there. But I also know that this edge on 11 would line up with that edge on 11. And since that's a longer piece, it might be more valuable to try to line up this edge to right there, so that those two pieces go together. It's possible, however, that we get some weirdness along the edge that won't make them line up quite right. And that's because this building twists. So in this context, unfortunately, even though they're close, it doesn't quite work. So I'm going to go back to 0. So we'll line up the zeros. So I'll go to rotate again. And we'll put that one there. And I'll take 2. And I'll rotate 2 to be right there. And I also have the bottom, which is 4. We can move 4 to be right there, and then do a rotate there as well. So if we were looking at this particular shape now that it's reassembled, if I were to cut that out and fold it together, that would end up being that shape right there. So it's pretty cool to see the association. If only you could do this in 130 when you were trying to create those shapes, right? This is a lot easier. 3D model, unroll. There we go. I'm done. Let me cut it out. So I can do the same thing with a curved surface. And I'm going to skip this one for right now. I'll do something slightly more complicated. I'll do this one. And this is, once again, a poly surface. Everything's joined. If I type unroll surface, select curves on poly surface to unroll, explode yes, labels yes, keep properties no. I'll go ahead and hit enter. I again get my labels, and I get my parts. So just like I did with this one, I'll take my parts. Let's move them up over here. There we go. And let's take that first one. Let's move 10. Rotate. Be there. 7. Oops. rotate. Notice I'm not using rotate 3D, I'm just using regular rotate. We can drop number 11 up top here. Rotate that. Number 6 here, and number 4. We'll move number 4 down. It really doesn't make any difference which direction you do this. Oops. Oh wait, I made a mistake on that one. Sorry about that. Wrong corner. It should have been over here. And then we could take this last one, and I could put it right here. As long as the numbers match up, the resulting shape can be different. So in this one, I went out all the way around 1. In this one, right, I went over, and that one's connected to that. It doesn't really matter the shape that you get, as long as the numbers match up. So there's another shape, and that then represents this curving shape. There's a little bit of a challenge when you actually go to physically assemble it, in that you have to kind of bend the paper as you work and glue and hold until it makes the curve that you want. But if I were to go to the laser cutter and cut this shape, cut this shape out, if I glued the sides together accurately, it would twist the way that it should. I have a couple examples in my office that I can show you of previous examples where they were glued together. As long as you make sure the sides line up, it will twist the way it's supposed to. So I have those two unrolled. Let's move to this one on the end. So I told you we were going to have issues with this particular piece because although it's subtle, this edge bulges in both directions. If I select this object, there's my poly surface, and I went to Unroll Developable Surface right there, I'd get this. Unrolling doubly curved surfaces will produce inaccurate results, period. I'm done. That's what Rhino says. So if your building happens to be like that, and it can be accidental, like in something like this, maybe I didn't mean to have that side pop out just a little bit, it just kind of happened when I did the cage edit. What that means is you have to go back in and recreate this particular piece. So what I would recommend is the dupe edge command, and create a duplicate of each of the 4 edges of your building. Or maybe you have multiple pieces and it would be more than that. And I'll go ahead and I'll create the top edge as well and the bottom edge. I'll hit enter. That gives me curves. I'll move those curves over. So essentially I have the outline of my building. But notice I no longer have that bulge anymore. That was in the surface. So if I take this and I loft the two together, I've gotten loft gives me a straight line connection between the two. I've gotten rid of that curve. I can then loft this to this. Notice I'm doing each side as a separate loft. If I were to do this plus this and loft them together, it would round the whole thing. That wasn't my intent. So instead, each segment loft, and then I could do this and this as well, and loft. And then I'd have to create the top and the bottom. Anyway, you're getting the idea of where I'm going with this. Loft. OK, so then I can take all of these surfaces. I can join them together. And then I can unroll surface, and lo and behold, it's going to work. So by recreating it with loft using control curves on the edges, I've essentially taken my building that didn't quite work and made it a building that would work, very much in the same vein. Now, if you have a building that's completely conical in shape and doesn't have any hard edges, this is going to be a little bit more challenging. You can, of course, slice up your building into lots of individual little strips and stack all the strips together. Though, in all honesty, the more pieces you have, the harder it's going to be to assemble. So the fewer pieces, the better. So let me do another example over here a little bit. And this one, I have a curve on the building. but I also have a little bit of an inset as part of the building. So if I were to do this, this is a little bit more on the complicated side. It is all lofts. They're all developable surfaces. So if I unroll surface and I get these results, I end up with more pieces, and I have to assemble those pieces together. So let's look at it in the top view. Let me go ahead and move this over a little bit. And now I have more pieces to kind of figure out how they come together. So we'll start with piece 2 there. We'll take this, and I'll move it to be on top of piece 2, and then I'll rotate. And then I would take piece 6, and we'll move piece 6. And then we'll rotate that. Looks like I might have had a little error. Yeah, I over-rotated those corners a little bit. So there are errors, but you get the idea where I can continue piecing those together. The difference here is that there's more individual little strips that are part of it. And so I'm going to get a slightly different result. So thus far, unrolling surfaces seems rather easy. And I want to take it a step further, and I want to look at the actual building right here that I did as part of my exercise. And I want to go all the way and create a lasercut file for this particular building. And I'm going to do a couple extra things along with it. So number one, I have all my floors still attached. So I'm going to take all of my floors. There's my floors. Let me select objects. I'm going to take all of my ceilings, and I'll select objects. And then I'll select my skin. And I'm going to type intersect, and I want that intersect to go on a new layer. So I'll type intersect. And the intersect is going to give me a series of curves that go along the outside of my building at the edge of every floor. Okay? It also gives me a bunch of curves that go down the middle. I don't really want those curves, so let me go back to my wireframe. Look straight down on this, and I'm going to select those curves and get rid of them because I don't really need those. So then we'll go back to shaded and look at this building. So I'm going to do the same unroll surface on the outer edge, unroll SRF, and it says select curves on polysurface to unroll. Thus far I've always ignored it. But what this allows us to do is any curve that is coplanar with the polysurface, i.e. all those floors that I just created, I can unroll those as well. So I'm going to go ahead and select all of those curves that were on layer 3. So let me select objects. There's all those curves. And I'll go ahead, explode yes, labels yes, keep properties no. I'll hit enter. And I now have an unrolled surface. But what I got was beyond the surfaces themselves, I also got all the curves that represents every floor plate. And this will help when we get to the actual lasercut file. So let me go ahead and move into the top view. Here's my pieces. Let's move them away from the origin a little bit. And I need to assemble those into their component parts. So let's take curve, or let's say 9, and let's move 9 so that it matches up with 9. There we go. Let me rotate. We'll flip that around so that it matches up. I'm going to be careful on it. There we go. Then we'll take 11. Now I have to be careful when I do the selections because there's a bunch of curves that are part of this. So I'll drag from right to left through the middle and select that. We will then move this to match up right there, and then rotate from that to that up to right there. There's that piece. We can put 10, go to move, put 10 to right here, and I'll move or rotate from there, there, to right there. 6, so from right to left through all of it, move, and then rotate. There. And my last piece right here, we will go ahead and move. That's right there, and then rotate. To right there. So I've assembled those pieces the same way that I've done everything else, but now it's time to start creating the actual lasercut file. So I'm going to create a layer called lasercut, which I happen to already have, and I have a cut layer and an engrave layer. So first thing I'll do is I'll make my cut layer active, and then I'm going to duplicate edge and select all of the curves that go around my shape. So I've gone all the way around my shape. I'll hit Enter, which will then create red curves that go around my shape. I can then take all the curves that represent the floors and the ceilings by doing two selections. There. Hold down Shift, and I'll go through these as well. There. But I want to deselect the surfaces themselves. So we'll get rid of the surfaces. I'll hold down Control, get rid of the surfaces. It's always helpful if you click on the center line that goes along the surfaces there. Oops, let me get rid of that one. There we go. And all of these curves I will put on the engrave layer. So let me change object layer. They're now on the engrave layer. I can then turn off layer 3, and we can see that I have engrave lines that represent all the floors, and I have cut lines that would cut out this building. Looks like I missed a few. The cross lines in that. So let me turn back on my surfaces. Let me dupe edge. Oh, let me put it on the engrave layer. Dupe edge. One, two, three, four. I also need that edge right there. I'll hit Enter, and now we can turn off layer 3. And we can see this laser cut file that's starting to materialize. So I could take this and do the same kinds of scaling operations that we did as part of our topography, and then walk over to the laser cutter and actually cut it out. Now, if I was doing that, though, these edges would cut out fine, but it's pretty hard to glue this edge to that edge when there's no little tab or anything to glue from. So what I like to do is I actually like to take all of the edges, or at least opposing edges, and I like to offset them. And usually the distance is about the distance between a set of floors, so maybe 16 feet or so. And as I offset that, okay, that represents an outer line. I'll do the same thing, oops, with this curve right here. We'll offset that one. I don't want to do it for here or for here, but I do want to do it for this side. You only need these tabs on one side or the other. So there and there, that's good. I can put one on the end here. That's going to glue to right there. I can either do the ends there and there, or I can do the sides right here and here. It's up to you. I'll do the ends. Oops. There. One. There's two. Now I need this to become red, so we'll change to the cut layer. Furthermore, these need to be blue now because they're folds, not cuts. So we'll take these. Oops. That one already is blue. And we'll change object layer. These are cuts. Change object layer. And we need a few other pieces that kind of connect these. So I'll go back, making sure I'm on my cut layer, and we'll draw a few other pieces. We'll go from there to there. We'll go from there to there. There to there. There to there. Now in here, this doesn't quite match up, so I'll just draw a line here to there. That one goes a little bit far, so I should probably trim. Oops, sorry, wrong piece. There. A few more little bits. There to there. There to there. That curve needs to be on the cut layer. All right, all of that looks good. One last piece right there. And so now, this object that I created, if I were to cut it out and assemble it, the floors will line up and represent every floor of my building on the model that I create. And I'll have little glue tabs that'll let me attach and get these pieces to come together after I laser cut the file. So my purpose today is to teach you to do unroll, make modifications to your building as necessary so that it will actually unroll, unroll it, and then create a file that looks like this with blue lines and red lines as if you were going to walk over to the laser cutter and cut it. I didn't do any scaling. I didn't put it on the actual page. You don't have to do that. I'm just looking for this in blue and red that represents cut and engrave. Let me move this down just a little bit so it's not so crowded against it. Notice that the labels have gone away after I assembled it because this is a new set of cut and engrave layers. So once I have this, I need to export it. And I said in the handout to do a print of it. Don't do a print. Go to in the top view, go to the little triangle, go to Capture to File. It'll save the exact image of what you're seeing on the screen. That's easier as a JPEG. That's what you're going to post today. Obviously, if you were going to cut this out on the laser cutter, you would export an AutoCAD version and take the AutoCAD version over there. So I'm going to let you guys work on this. If you have extra time, work on assignment 203, which I know isn't due until after spring break, but you guys are going to forget everything you learned on spring break anyway, so you might as well do it now, and then you won't have to worry about it. Okay? I'm going to go over to the laser cutter room. I'm going to cut the sample topo file. I have cardboard to cut. I'll cut it. Then I'll sit down in the back, and if somebody will let me borrow some glue, I will call anybody who wants to watch me glue it together over, and you guys can watch me glue it together, or at least part of it together, so you get the strategy for how it glues together. Okay? So I'll disappear probably for 20 minutes while I go laser cut the file, and then I'll demonstrate that, etc. The what? No, it's okay. I have mine ready to go. I appreciate the offer.